Welcome to today's video. Today's learning target is all about the tangent ratio. So let's start off with a warm-up, taking a look at our first example here. So we have a right triangle with an angle of 39. They want us to find the opposite side of angle B. The opposite side of angle B would be the side AC. Since we have a hypotenuse, which is always across from the right angle, always the biggest side, and the adjacent is always the side that's touching it. So we have an adjacent and an opposite and a hypotenuse. So our side would be AC. If we want to say the side that's adjacent, technically the hypotenuse is adjacent to our angle, but we never want to use the hypotenuse as our adjacent. So our adjacent side, we're talking about the adjacent leg. So that would be side A, or we could say side B, C. So trig ratio. So let's take a step back and think about our angle-angle postulate. So anytime we have two triangles and they have two congruent angles, so we have, in this case, these three triangles have both a right angle and a 32-degree angle. So since they have two angles, we know the third angle must all be congruent, and therefore if all the angles are congruent, that means that they're similar, meaning that they have the same shape, not necessarily the same size. We can see that looking at this, they all have the same shape, but they're like, we have a small, medium, and large triangle. So if we know that they're similar, we know that they are proportional. So this is just proportionals are just fractions set equal to each other. So that's something that we spent a lot of time talking about in our last unit. So basically, they all have a similar scale between the sides. So these are trigonometric ratios. So a trigonometric ratio is a ratio between two sides of a right triangle. So we're going to be specifically looking at the side. So the angles kind of just tell us, hey, we can use this ratio, but we're going to be specifically looking at the sides. The tangent ratio is the ratio specifically that we're going to look at today. There's a couple other ones, but we'll look at those at a different time. The tangent ratio of an angle is the ratio of the length of a leg that opposite of the angle to the length of the leg adjacent to the angle. So if we take a look at our tan A, so here's our angle A is over here. So the opposite side would be this A, so it's opposite, and our adjacent would be this B. So if I put opposite over adjacent, we would get this A over B. Now, if I were to change my angle, so would my opposite and adjacents. So if I changed, let's hypothetically say tangent of B, so our B is here, so this is our angle. Therefore, our opposite would be B this time, and our adjacent would be this A. So we would write B over A. So the tangent ratio, basically, taking those side lengths and putting them over each other. We just want to make sure that the opposite goes on top and the adjacent goes on bottom when we're talking about tangent. And then these A and B spots, this is typically where we put an angle. We call that angle, sometimes we call it theta. Theta is just a fancy version of x whenever we're dealing with degrees, rather than using x, because a lot of times we're trying to find side length x, we'll just use theta so that we're not confused. So writing tangent ratio, so this is a little bit of practice with applications, actual numbers of this tangent ratio. So I'm going to put a big square and star this is really important, this tangent ratio, because that's what we're going to be using all day today. So we have a triangle over here to the right. They want us to find the tangent of S. So S is right here. So I want to figure out which one's my opposite, which one's my adjacent. So we have our opposite and our adjacent. Again, these are the legs. The hypotenuse we're not going to use. In fact, we're not going to use for tangents at all. So the hypotenuse is kind of just an extra piece of information for right now. We'll use them on different ratios. So the tangent of S, our opposite was 60. Our adjacent was 25. We could reduce this fraction, and that would be great. They're both divisible by 5, so we get 12 over 5, which if we divide that as a on our calculators, we get 2.4. They're asking for 4 decimal places, so we'll throw a couple extra zeros on there. If we took a look at tangent of r, that's going to change up where our opposite and adjacents are. So our tangent of r, our angle is here, so therefore our opposite is going to be this 25 this time, and our adjacent is this 60, so it would actually look like 25 over 60. Notice that they flip. That's because we've changed directions. We changed which angle we're looking at. And since there's only 2 numbers that we can use for, because there's only 2 legs and there's only 2 spots in a fraction, obviously there's only so many combinations that we can do for these. So when we change the angles, they kind of just flip. So when we do 5 divided by 12, we get about 0.4167. So that is just setting up our ratio. So anytime we're trying to do a tangent, or tomorrow we're going to talk about sine and cosine, whenever we're trying to find those decimals, we're going to go 4 decimal places. So also known as 10 thousandths. We're going to do a little practice with our calculator, making sure we're in the right mode. So when your calculator's in the wrong mode, you might feel betrayed. Meh, kitty. Do our tangent of 57. So go ahead and hit, some calculators you might have to hit the tangent button first and then hit 57, enter. Some calculators you might have to hit 57 tangent, and then your answer will pop up of 1.5399. Again, we're just rounding 4 decimal places. So if you didn't get that answer, make sure you check your mode. So it could be, just make sure that there's a degree or a D or something indicating you're in degree mode on your calculator. Tangent of 28.5, we should get about 0.5429. So just a way to double check we're in the correct mode, because on the back side we're actually going to be using that button to do some calculations so that we can apply this ratio. But before that, let's take a look at something we're a little bit familiar with already from last week. We talked about, or earlier in this unit, we talked about special right triangle. So here we have a picture of a special right triangle. And what I'm going to do is, instead of doing sine, we'll do that tomorrow. Let's talk about the tangent of 60. I want to see if there's a relationship here. So here's my angle, 60 degrees, and then we have an opposite and an adjacent. Oops. So if I make my ratio, so even though these expressions don't have a number, there's an s, so we have s times the square root of 3 over s. This essentially is just our formula for the special right triangle. What we're going to find is that this special right triangle stuff works out with this tangent stuff. So if we cancel those s's, because if I multiply and divide by an s, they would just kind of go away. We would be left with the square root of 3 on that side. When I do the tangent of 60, the tangent of 60 is about 1.732. The decimal keeps going on and on. It's irrational. Actually, what we find is that the square root of 3 is also that same decimal. So what we did was we just used special right triangles to prove this tangent ratio works. So I tricked you into a proof. Even though it didn't look like a proof, hey, we just did one. That's about as much proofs as we're going to get into this unit. So if that seemed really easy, then well, that was essentially the proof of the unit. So taking a look at our example 3. So this example 3 is like the epitome of our learning target. So it's really important that if you're feeling confused about this portion, that we're going to check in maybe before school, after school. Send me an email. I can make an extra video for some, or help you out, or send you a link of some extra examples and stuff like that. So what we're going to do is we're going to apply this tangent ratio. So the first step that we're going to do is we're just going to plug in. So just like what we've been doing on the front, so it's going to seem really familiar at the beginning, and then we're going to get some decimal answers. So we're going to simplify whatever we can to just get decimals, so get rid of those fractions. I know that sometimes fractions can be intimidating, so we'll turn them into decimals, and then we're going to solve. So if there's a variable left over, we're going to figure out what that is using our algebra. So to start us off, side AB, let's call that side Z for right now, so that we're just solving for a variable. They give us a reference angle, 41 degrees. So since, spoiler alert, we've been talking about tangent, it's probably going to use the tangent ratio. We have this opposite side, they tell us is 6.1. Z is actually our adjacent, so we're just finding our adjacent. So since the tangent ratio is opposite over adjacent, we're going to do the tangent of our angle, which is 41 degrees. So tangent of 41 equals our opposite, which is 6.1 over our adjacent, which is Z. Then we're going to simplify, find out what this tangent of 4.1 is. Just like we did at the bottom of this page, we're going to turn it into a decimal, making sure we're in the correct mode. So the tangent of 41 degrees is, we're going to go 4 decimal places. Whenever we hit that tangent button, we get 0.8692. I rounded up, I believe, a little bit. So on the other side, we still haven't done anything with this fraction. It'd be nice if we could get that Z out of the denominator, because that would probably be really helpful. So let's do that. So the opposite of division is multiplication. So when we do that, we're going to be left with 0.8692Z equals 6.1. And in order to get Z by itself, we're going to divide both sides by that decimal. And our Z equals 7.0179. I could just, let's just round this because it says to the nearest hundredth, which is 2 decimal places. We'll just go like that. If you want to just go 4 decimal places all the time, totally. If you're feeling kind of confused about when, like, so here we had to go 4 decimal places because we hit that tangent button. If you want to just across the board go 4 decimal places, that's fine. We definitely need to whenever we do that tangent button, or tomorrow when we talk about sine and cosine. So 4 decimal places is kind of our whenever we're using one of the trig functions, but if we're giving our answer, we can go with whatever the directions tell us to. So the reason why we do that is just because if I went 0.86 or 87, it would drastically change this. This answer might change by like 1 or 2 entire units, so it will like make it either much bigger or much smaller depending on how we round. So we don't really want to round that much. That's why we go 4 decimal places. Taking a look at our next example, so taking a look at this triangle, we have this angle is 72. The opposite side would be this x, so I'm going to just label that opposite. My adjacent would be this 36. So I'm going to just set it up just like we did before. We're going to do tangent of our reference angle. This time is 72 degrees equals our opposite, which is x, over our adjacent, which is 36. So just depending on, in reference to that angle, that's why we call it the reference angle, which side is the opposite and which side is the adjacent. So since this 36 is touching the angle, that's why it's the adjacent, and since this x is all the way across the triangle, that's why it's the opposite. And this would be our hypotenuse, and just like I said before on the front, we're not going to use our hypotenuse with the tangent ratio. We're going to use it with other ratios, but not the tangent ratio. So just like we talked about before at the beginning, we plug them in, so that's done. We're going to get the decimal, so the tangent of 72 degrees, beep, bop, boop, that's my calculator sound effects. After I round 4 decimal places, we get 3.0777, and we still have this x over 36. So then I'm going to get rid of that 36. The opposite of division is multiplication, so I'm going to multiply both sides. These will cancel. We're going to be left with x equals 110.8. If you didn't round, you would get 110.7966, like I believe it's repeating. So since it says to the nearest hundredth, this would be fine. This is totally fine. I'll take this answer, either of those. So again, if you're feeling a little confused, or feeling a little worried about when to go 4 decimal places or when to go to 2 or something like that, just If you want to just go 4 all the time, that's fine. Nothing wrong with being super accurate. So the last one, we're going to do an application. So a contractor is building a wheelchair ramp for a doorway that is 1.2 feet above the ground to meet ADA guidelines. So we have these things, contractors typically refer to them as codes. So these codes are just legal guidelines that in order for everybody to remain safe. The ramp needs to be an angle of 4.8 with the ground. So we're going to the nearest 100th of a foot, so 2 decimal places, we're going to find the horizontal distance. So just like I always say, let's draw a picture. So I'm going to draw a picture. Here's my ramp. And they tell us that, so there's like a door up here. So that means that this is 1.2 feet up. Hopefully our walls are straight up and down, aka perpendicular, aka 90 degrees. I have seen some houses that are slanted before, but I don't particularly, I wouldn't want to live in one. We want to find this distance, the horizontal distance. So this would be our X, and they tell us that the legal requirement is this 4.8 degrees, so I'm sure that is a very small angle because we don't want to slip on our ramp, especially with it if it's winter in Minnesota. So I noticed that I have an opposite and an adjacent. Now we could use a different ratio to find our hypotenuse, and that would really help us figure out our materials. But today, since we're just figuring out the horizontal distance, we're going to use the tangent ratio. So because we have an opposite and an adjacent, so we're going to do the tangent of our angle, which is 4.8 degrees, equals our opposite, which is 1.2 over our adjacent, which is x. We're going to do our decimal. So tangent of 4.8 is about point, we're going to go 4 decimal places, 0.839. We're going to round that up to 3/7 to maybe go 40 equals 1.2 over x. Multiply both sides by x. Now there is a shortcut to this. This part that I'm doing right now, where I'm multiplying both sides by x to get it out of the denominator. If you do figure that shortcut out, please keep it to yourself for right now. If it will be much more memorable, people will remember it, and it'll make their life a lot easier if they figure it out on their own. Last thing I'm going to do is this divide to get our x by itself. And our x equals 14.29 feet. So we want to go 2 decimal places. If you have any questions, make sure that you just send me an email, or you can stop in before or after school. I can always send you some extra links for some extra examples if you want. Please make sure that if you're feeling a little unsure, to go ahead and check the partial key to see if you're setting it up correctly. And thank you for watching.